So the last section was about the fundamentals of computing, right? So in our perspective, we have seen what is meant by computing, right? Computing is merely an activity, that's it, right? Computing is just an activity. In this computer science domain, we see computing involves technology to manage, process, and communicate information. For doing these three sort of things, we use something called what? Computers. The lecture started with what is meant by computing. Okay, and for performing the task, that is computing, what do we need? Computers. So what is this computer? And what are this generation in which it has evolved? All those things we have seen. These are all supporting things. These are all the supporting things, right, that we have learned. And then we have seen what is meant by a problem, a computational problem, right? So what do you mean by this computational problem? Huh? What is computational problem? Manish, we are solved by algorithm. What is solved by algorithm? What? Exactly. Solving a problem through an algorithm. That is called a computational. If it is solvable, then it is called computational problem. Okay, good. So any problem which is solvable through an algorithm, we call it as a computational problem. So once discussing this computational problem, what we have seen? The different types of computational problems, right? Yes or no? What are the different types of computational problems? Yeah. Okay. Decision problem, search problem, optimization problem, and coding problem. So these categories of problem we have seen. And then finally, we have seen what? A simple example demonstrating a computational problem. Yes or no? A simple problem demonstrating a computational problem. In order to solve a computational problem, what do we need? Two things that are important, right? Exactly. The representation. The second thing, algorithm. So that last lecture, algebraically we have seen how to represent a problem, right? So how to represent a man, cabbage, goat, and a wolf, right? How to represent them. Fine. Representation is fine. How about this algorithm? What this algorithm actually does? You know the definition, right? But what it takes and what it gives, and how algorithm should be written, and what are the ways in which algorithm can be represented. Okay, algorithm is just a procedure. Implement procedure can be done in different ways. Okay, so that's what we're going to look into the today's lecture. Algorithms. Okay, so this lecture will get an idea about what an algorithm and what are the essential things required for an algorithm. How you see algorithm algorithm. Okay, and you'll see what are the different representations we can use in algorithm. Okay. So according to you, what is an algorithm? Step by step process. Then what is a process? Process or procedure? Procedure. Procedure, executing procedure only gives you a process, right? The entire procedure is what you're executing the procedure will lead you to a process. Okay. Yes, sir. So classically, defining an algorithm in your own way, step by step procedure. Right? So algorithm is input and it produces the output. What is the connection between the input and the output? Yes, what is the connection between this input and the output? Algorithm is acting on this input and it is yielding something, right? Yes, sir. Your juicer is taking apples and giving you apples. right? And user is taking apples and they give you apples. Okay, around that. Apple photo will be every apple. Apple photo will be apple and yeah. It's not a single choose. Apple is say 22K. Yes. Choose. You can choose. So the transition. Okay. The conversion. Algorithms. Okay. So what? Algorithms. Each and every step will be convert input to one output. Okay. So what is your step to convert apple into juice? What all you'll do? You have apples, you have juice. What all you'll do put to transform the apple into juice? Ajay, what will you do, Ajay? You have apples, I need juice. What do you do? Some precise instruction is fine. Cut the apple is good. Second one. Heat and put it in. Very good. Put it in the jar. Add some more milk. Sugar. Mix it with mixing it. Okay. Turn on the jar. Okay. Let the jar run for 2 minutes. Turn off the jar. Pour it into a glass. Pour it into a tumbler. That's all. And then large glass. Okay. Good. See? That's what your algorithm is. Your each and every step is transforming the apple into a juice. Okay. The milk is skipping what the sugar. What did you get? Yes? Yours kind of rose milk. How will you get rose milk? Okay. The final outcome will be not as expected, right? So we algorithm is about that. Okay. So in such a way, algorithm should be there. Okay. Outcome should be as expected. Clear? So what's this algorithm says actually? What this algorithm is for? Any idea? This is an algorithm, right? It's algorithm. Okay. So the algorithm says. The guy has to enter inside of. Okay. This one. Just a real world scenario which is being. So start. Knock. What is it? Yes, just say it. Not it. Just take it out. That's all. Okay. Just simple. So you're coming out of ground. Okay. Let's say there's a PT period, no one is there in the class, everyone is in the ground. Okay, everyone is coming from the ground. Let's observe it. What is there in the class? Come inside, sit, open your book, read. What do you do? Reading. Out of that, very welcome. See the notes, everyone will do right. Yeah. Okay. So, see, this also simply view it as step-by-step procedure. Okay. Everything in the real world we can just try to view in a algorithmic fashion. So, what should be the characteristics of an algorithm? How it should be? Does an algorithm need character? It's not a human, right? Does it need a character? Yes. Why need a character? Algorithm requires a character. Yes. If it is not regulated by a character, what will happen? Yeah, the outcome won't be as expected. So the algorithm has some characteristics. If it sticks on to the characteristics, then definitely what will happen? The outcome will be very good. Instead of putting apple juice by avoiding the water, milk, and sugar, okay, let's say you don't know how to put a juice, okay, that maybe you are. Let's see, for example, who will drink your juice? No one, right? No one will come near itself, right? So on the other hand, if you're using a small cookbook, a small sheet where you have every instructions, okay, you follow the instruction, definitely you'll be getting good juice, right? Because those cookbooks, those instructions and all, they'll be very precise and very clear. Okay, such that the final outcome will be as expected as possible. Okay, even though you don't get a good solution, you'll get a better solution. Okay. So the characteristics, so every algorithm should be accurate. Okay. So whatever you want, just specify it clearly. Got it? Don't specify it clearly. What will happen? What will happen? Catastrophe, right? So let's ask you, let's ask it, okay, small order. ஒரு கரண்டி உப்பு வந்து ஒரு பர்டிகுலர் டிஷ்ஷுக்கு போடுன்னு சொல்றீங்க. What the child will think? Spoon எடுக்கணுமா? பெரிய கரண்டி எடுக்கணுமா? Among these two things, what the child will decide? The child will be in a confusion, right? So what the child will decide? Correct spoon எடுத்த பிரச்சனை இல்லை. அது கரண்டி எடுத்து அவ்வளவுதான் இல்லையா? So the computer is also like a child. It is brainless. It's very of course, what I would say here is more questions. More questions. Right. So whatever we say, we have to specific. So do this. So you did a titration experiment in chemistry. Then you'll specify ml, right? So add the solution, this ml, add that solution, this ml. Instead of this ml and that ml, I mean 5 ml or 6 ml. Okay. Add more. Add solution into the beaker. What some more means? What is some more means? We don't know, right? Give me money about 500. Give me money about 500. What is about 500 means? That's not 500. Give me 500 means it's easy. I'll give you 500. Give me about 500 means one is having a strong fever. What do you mean by strong? That we can understand. We have intelligence. We can understand. It is 101 or 102 approximately weekends. But according to the computer, what do you mean by strong fever? What do you mean by that? So there are not many ambiguous terms in English. Okay. So whatever we are trying to specify in an algorithm, it has to be clear. One is having a fever of 1 or 2 degrees Fahrenheit. So that is accurate, right? Yes or no? That accuracy is sufficient. Okay. An algorithm should be written in sequence. Why sequence is required? In some problem, if you miss the sequence, also no problem. It will work out. But some problems, the sequence is really, really important. You skip the sequence, that's all. Right? So while doing the T, some statements can be shuffled and returned, right? So which statements can be shuffled and returned? Can anyone say what's the instruction you should follow to put a T? Anyone? Who's going to say? Who's going to say? From the men's side or from the women's side? From the women's side or men's side? Yeah? Which one? I need some volunteers. Who puts size T? Women or men? What is on the start? Okay, all over. Yeah. Let's see better. What are these? Please. What comment is there? See better. See better. Right? You cook at home, right? When you're cooking now, in my students are cooking in their room. They prepare more dishes apart from the tea. Yeah. So you will also learn the second year or third year to learn many things. But yes, how many of you have put tea before? Participate, guys. Without participate, one. அந்த தலையை இது பண்ற மாதிரி கூடாது. நல்ல கை தூக்கும் சரி. Great. You. Here, Dharani. That is me. There. Great. You're also good. Okay, good. In the game, okay, just the vessel. Then on the tap water to the vessel. Add this in some small water. One watt. Tap for piece of water. Allow it to come 3 points. Okay. And then I add with that, add some number of with that thing. And then after according to and then someone right. This could be skipped. The people sorry. Other examples. Anyone know what the examples are? Yes. Yeah. You oh, I don't think you are. Mother, sorry, mother. Mother, you are in my pre-on coding, right? You remember the example? Mother used to be there. I think in the beginning of the class also I mentioned the example, right? Yes, sir. Yeah, Mother, do you remember? Sit down, mother, sit down. Okay, how many of you attended my? Yeah, I think you also attended my pre-on boarding, right? The last person. Yeah. What's your name? Sorry, Akshaya. Kanishka. Kanishka. Remember? You two attended, right? You remember? Let me say, you all know. But you are afraid to continue anything. Sir. All right. Very good. All the people, but you are afraid to say, come and say it. Yeah. You agree with? Yes. Alan, you agree? Okay, let's start. Another thing. You say, so here, every morning, you yes. Right. What right? Issue. First, other day you are telling up this is what, right? What people think about you? You're from Mars. Okay, right? So that's the right sequence, right? You know all the sequence, what people are saying. Okay. So therefore, sometimes the sequence are really important. If you are expecting the right end thing, I mean, you have to follow. Third thing, the instruction. Okay, the normally is there. I don't have to guess. Something your friend might ask you. என்ன முன்னாடி சொன்னியே திரும்ப இது எதுக்கு என்கிட்ட சொல்ற? Computer won't ask like that. Okay, but we humans we should have the responsibility. So we should write the algorithm in such a way nothing should be repeated. Okay. In artificial intelligence, there is a topic called planning. Okay, there is a topic called planning. Okay, The robot, it automatically will develop a plan and it will do a task. You don't have to instruct it. It will automatically do it. Okay. In that planning, there is an anomaly called as suspense anomaly. என்ன அப்படின்னா செஞ்ச வேலையை என்ன பண்ணணும் அப்படின்னா அண்டு பண்ணணும். It will undo the task, not to do the another task. அந்த மாதிரி சிச்சுவேஷன்ஸ் இருக்கக்கூடாது. அண்டு பண்ணிட்டு திரும்ப அதையே செய்யும். சரியா? இதெல்லாம் கொஞ்சம் ஹையர் லெவல்ல நீங்க படிக்கும் போது suppose let's take you're doing one task. Let's take the shoe task itself. Daily morning உங்களுடைய டாஸ்க் என்ன அப்படின்னா ஃபர்ஸ்ட் ஷூ வந்து போறதுக்கு முன்னாடி ஷூவை தட்டுவீங்க எல்லாருமே. தட்டி பார்த்துட்டு அப்புறம் என்ன பண்ணுவீங்க? லேஸ்லாம் கட்டுவீங்க. ஒரு சில பேர் என்ன பண்ணுவாங்கன்னா கொஞ்சம் பயம் இருக்கும். சாக்ஸ் என்ன பண்ணுவாங்க? கம்ப்ளீட் எடுத்து நான் எனக்கு எதுவுமே ஆயிருக்கும். நான் என்ன பண்ணுவேன்? கீழே தட்டும் போது நல்லா ரொம்ப குட்டியாடு. Okay, so some of you might have that sort of habits. Okay, let's say you are programming a computer. You are programming a robot to do that. Robot என்ன பண்ணுது? கால் வந்து ஃபர்ஸ்ட் ஷூ கட்டி பாக்குது. செகண்ட் சாக்ஸ் என்ன பண்ணுது? ஓபன் பண்ணி சாக்ஸ்ல இருக்க செக் பண்ணுது. செக் பண்ணிட்டு என்ன பண்ணுது? அதுக்கப்புறம் சாக்ஸ் ஷூ. ஓகே, வாட் ஃபைன். சப்போஸ் நீங்க செக் பண்றத வந்து மறந்து செக் பண்றது சொல்லாம இதெல்லாம் போடுறதுக்கு சொல்றீங்க. அப்ப என்ன பண்ணுவோம்? திரும்ப லேசர் கட்டி சாக்ஸ் பண்ணி அதுக்கப்புறம் என்ன பண்ணுவோம்? ஷூ திரும்ப கட்டி திரும்ப சாக்ஸ் போட்டு திரும்ப லேசர். ஸோ ஏற்கனவே செய்யற விஷயத்துல நீங்க ரிப்பீட் பண்ற மாதிரி இருக்கு. ஓகே, அதனால கரெக்டா உங்களுடைய அல்காரிதம் இருக்கு. அதுக்கு சீக்வன்ஸும் ரொம்ப முக்கியம். And the fourth thing is your algorithm should terminate. Your algorithm terminate. In such a way, you should design an algorithm. If you don't terminate the algorithm, what will happen? What will happen? Your algorithm will endlessly. There should be some condition to stop it. Okay, fine. Last one, it should look like normal English. Algorithm ரொம்ப confused ஆயிடக்கூடாது. நீங்க படிச்சு பார்த்தீங்க அப்படின்னா உங்களுக்கு புரியும் written. Okay. Next, steps for developing an algorithm. It's a breakdown 1045, right? What's yeah. Yeah, there is any opinions? Exact what I was like. Understand the problem. Okay, understand the problem. So without understanding the problem, you won't be able to solve the problem. Got it? So without understanding it, you won't be able to solve it. So we have worked with the candy problem, right? Candy counting problem, right? And the mango tree problem, right? Solve the problem once you're able to define a solution to the problem. Next. Okay. Fine. Problem. Let's say I have a okay. So how much many eggs do you have? How many eggs do you have? What are the eggs? What are the eggs? What are the eggs? But number. Yeah, I know so. In the area of the so what is the solution? Thousand word theory, right? Riddle. Exactly, 70. Okay. We have one more thing. Solution also change, right? We see the first thing that then only the thing is like I add one more thing. The also change, right? The riddle of fixed is only something will be here. Right? Or it's a negative. Right? That was all good. Nice man. Nice. Hey. Okay, problem was the part solution for or 11 சொன்னீங்க 17 சொன்னீங்க அந்த மாதிரி நிறைய ப்ராப்ளம் கிரியேட்டிங் உன்னால சொல்யூஷன் கொடுக்க முடியும் வாட் இதே ப்ராப்ளம் வேற மாதிரி கேட்கிறேன் ஓகே சோ நிறைய குருவி பறந்து வருது நிறைய பேர்ட்ஸ் பறந்து வருது ஒரு பூ மேல உட்காருது சரியா மூணு மூணா உட்கார்ந்தா ரெண்டு குருவி மிச்சம் how many points are there பண்ணி வருது சரியா மூணு மூணா ஒரு புள்ளிக்கு வந்தா ரெண்டு குருவி மிச்சம் அதேதான் நீங்க எக்ஸுக்கு பார்த்ததுதான் இங்க ப்ராப்ளம் மாறுது ஆனா விஷயம் வந்து ஒண்ணுதான் வந்து இல்லையா அப்போ உங்களுக்கு ப்ராப்ளம் கரெக்டா புரியுது ஓகே உங்களுக்கு ப்ராப்ளம் கரெக்டா புரியுது என்கிட்ட ஒரு பெரிய நூல் இருக்கு சரியா இவ்வளவு பெரிய நூல் இருக்கு இவ்வளவு பெரிய த்ரெட் இருக்கு அது 15 சென்டிமீட்டர் சரியா 15 சென்டிமீட்டர் இங்க இன்னொரு நூல் இருக்கு 3 சென்டிமீட்டர் சரியா அல்லது 6 சென்டிமீட்டர் 15 சென்டிமீட்டர் இன்னொரு 6 சென்டிமீட்டர் இந்த ரெண்டு நூலையும் எக்ஸாக்டா மெஷர் பண்றதுக்கு ஒரு குச்சி வேணும் அதோட சென்டிமீட்டர் பண்ணணும் ஒரு நூல் 15 சென்டிமீட்டர் இன்னொரு நூல் 6 சென்டிமீட்டர் இந்த ரெண்டு நூலையும் ஒரே ஒரு குச்சி வச்சு தான் மெஷர் பண்ணணும் அப்ப அந்த குச்சியோடைய லென்த் எதுவா இருக்கு எவ்வளோ 15 மட்டும் மெஷர் பண்ண முடியும் 6 6 வைக்கிறோம் திரும்பி 6 வைக்கிறோம் 12 இன்னொரு வச்சா என்ன ஆகும் 3 சென்டிமீட்டர் எக்ஸாக்டா மெஷர் பண்ண முடியாது இல்லையா எக்ஸாக்டா முடியும் குச்சி வச்சு எக்ஸாக்டா சாக்லேட் சரி நான் காட்டுறேன் உங்களுக்கு ப்ராப்ளம் புரியலன்னு நினைக்கிறேன் see you have to understand the problem for solving this okay ரொம்ப சிம்பிள் தான் ஒரு விஷயம் கிடையாது சரியா இது ஒரு 6 சென்டிமீட்டர் இருக்கா நீங்க ஒரு குச்சி ரெடி பண்ணணும் சரியா ஸ்மால் ஸ்டிக் like a divider பார்த்து நீங்க காம்பஸ் யூ சேல் ஆன் பண்ணலாம் ஓகே அத நீங்க பண்ணலாம் ஒரு ஒரு சின்ன ஸ்டிக் இருக்கு இல்லையா இந்த ஸ்டிக் வச்சு நீங்க மெஷர் பண்ணணும் முடியுமா எக்ஸாக்ட்டா இந்த ஸ்டிக் இங்க க்ளோஸ் ஆகும் அப்ப அந்த ஸ்டிக் உடைய லென்த் என்ன வரும் எவ்வளோ 3 வேற ஆன்சர் என்ன ஆன்சர் வருது 3 வேற ஒப்பீனியன் தானே இதுதான் ஆன்சர் கிடையாது எவ்ரிதிங் இஸ் ஒப்பீனியன் 5 ஓகே அதாவது ரெடி மெஷர் பண்ணணும் இத மட்டும் கிடையாது ரெண்டையும் அந்த ஒரே சிங்கிள் மெஷர் பண்ணணும் 1 ஓகே வேற 1 வேற இருக்கா மாட்டத்து போக மாட்டீங்களா சரியா நீங்க வெளியே போறது அப்படியே ஆட்டோமேட்டிக் ஒருத்தர் போய் டிஸ்டர்ப் பண்ணாதீங்க சரியா போயிட்டு வந்து பாருங்க 5 3 5 கரெக்டா 7 okay 1.5 1.5 is also like this Let's stick on to the integer, not fractions. Okay, okay, but let's stick on to the product states only integer, not fractions. Then discuss the fourth solution 1, 2, 3, 4. Okay, if you go over 7, this we can't measure this. It's going out of this thread, right? The node of it from the very you can't measure this. ஒரே விஷயம் தான் மெஷர் பண்ணணும். Yes. So next one. One is measure பண்ணலாம் இல்லையா? இப்ப ரெண்டுல ஈக்குவலா மெஷர் பண்ணு கரெக்ட்டா? ரெண்டுல ஈக்குவலா மெஷர் பண்ணு. எவ்வளவு மொத்தம் மெஷர் பண்ண முடியுமோ 1 2 3. இங்க 15 times எடுத்து மெஷர் 6. 6 right? 6 times எடுத்து மெஷர். ஆனா எனக்கு எந்த ஒரு 1 கைடா இந்த கொஞ்சம் ஹையர் பண்றாங்க. ஹையர் நம்பர் பட் ஈக்குவலா மெஷர் பண்ணு. கரெக்ட்டா மெஷர் பண்ணு. இந்த வேல்யூ. இப்போ 3 ஆ 3 தான் இவங்க 5 இருக்கா? 5 ஈக்குவலா மெஷர் பண்ணா ஒரு பாயிண்ட் பண்ணு. சரியா? இந்த 3 ஈக்குவலா மெஷர் பண்ணா 1 1 இங்க 3 4 5 equal measure rather stick measure. So what this problem is? The problem என்ன சொல்றாங்க மேத்தமேட்டிக்கா? It just find GCD of two numbers. ரெண்டு நம்பரோட GCD கண்டுபிடிச்சிட்டீங்க அவ்வளவு. ஆனா ப்ராப்ளம் அப்படியே இருக்காது. Problem is completely different. How many is not make this arithmetic in this beyond money? That's something called as make this arithmetic. So problem பயங்கரமா இருக்கும். ஆனா அல்டர்னேட் திங் வந்து பாத்தீங்கன்னா that's very simple. Finding the GCD of two numbers. Okay. So defining the problem has to be very clear. For that, we need to understand the problem. So once you understand GCD only, like so many problems you can design. So many problems you can design just by using GCD. I will find some. All of this three problems are depending GCD. Written this page is in the sky bubble parameters, self-observation GCD. And third problem. Okay. So ஒரே விஷயம் தான் ஆனா மூணு விதமான ப்ராப்ளம்ல அதே தான் நான் சொல்ல வரேன். Okay. Second one, list the inputs and output. என்ன input வேணும் என்ன output. GCD of two numbers என்ன input வேணும் உங்களுக்கு? For the problem GCD of two numbers, what is the input you need? Exactly two number ரெண்டு நம்பர் இருந்தா போதும் you can find the GCD. Output என்ன வேணும்? Output என்ன வரும்? நம்ம கொடுக்க முடியாது. வெளியே வரது output. What will you say? Sorry. What's the output of the GCD? Two numbers. One. The problem here. GCD of two numbers and the output. Get the first question. Right? Sorry. Number GCD. Both sides of yes. That's what I'm okay. Then we getting the GCD as the output, right? Two numbers GCD we are trying to find, right? That's the output. So the output we have to clearly define. Got it, guys? The third step, describe the steps needed to convert the input to the output. Okay. What is the third step? That's the important thing. Describe the steps needed to convert input to output. What it means actually, what you're trying to do in the third step. The third step is a very important thing. The third step is your actual algorithm. The third step is your actual algorithm. Got it? This algorithm is what transforming the input to the output. Clear? The last thing is testing the algorithm. Okay? Testing the algorithm. Sometimes the algorithm will work, but not as expected. So how do we ensure that works for every case, for all the inputs, whether it will work correct or not correct? How will we check? Let's say they are designing a car. Taking the car is about on the bike is about 20,000 rupees monthly. Okay, but they say that we don't do any testings. We just down to some screws and something we did it. You accept the bike? Huh? Why people rejected Tata Nano? Do you have any idea? Sorry? Model failure. Why? Exactly. Like you said, there are some technical difficulties for that also. But there is one important thing people never notice. Well, exactly. Both of it correct, but people didn't notice the technical part. People won't notice the technical part. People just ask me what is the car in my car. Okay, they will tell. It is what a car. Why is it like people technically but getting noticed probably கார்ல கிராண்டா இருக்கா பாக்கிறதுக்கு எல்லாரும் பார்த்த கார் நல்லா பிரமாதமா மாதிரி சொல்றாங்களா that's what people notice, right? Think Tata didn't make that, right? Tata marketed in different perspective. இல்லையா? எல்லா நியூஸ் பேப்பர் என்ன போட்டாங்க? எல்லா நியூஸ் பேப்பர் என்ன போட்டாங்க? சீப்ன்றதை விட ஏழைகளுக்கான காரணம் போட்டாங்க. That's a major marketing problem there. ஏழைகளுக்கான கார். In Tamil Nadu, especially in India, why people buy car? For traveling. One thing is traveling. Why they buy car actually? Correct. So, அப்ப ஏழைகளுக்கான காரை யார் வாங்குவா? பணக்காரங்க காட்டுறதுக்கான காரை வாங்குறாங்க. Yes sir. For some people, not every people, for some people. But ஏழைகளுக்கான காரணம் யார் கார் வாங்குவா? அந்த கார் வாங்கினா என்ன நினைப்பாங்க எல்லாருமே? அப்படின்ற ஒரு மைண்ட் செட் இருக்கு இல்லையா? That mindset killed the majority of the people. That is one of the failure for Tata Nano. Okay, but some people throw that away. That my friend is also having Tata Nano. They just throw that thoughts and all. They just need something. That's it. So yeah. So sometimes we have to test it. Test every sort of possibility. When you work on coming back to the algorithm, you have to check the algorithm. You have to random watch the inputs and output. Like the program related or a input code work. So output. So output. Negative work. So then, how can we work this Fibonacci series? The schools or anywhere. You want to questions? I won't ask any questions, okay? I will just turn okay like this. You can raise your hands. Okay, hold on. So in my school days, what happened? I think plus two. Okay, Fibonacci series was my university public question. So I did take a Fibonacci pass. It was simple question. Sir, extent or as an I get ஏன் அப்படின்னா அந்த ப்ராப்ளம் வந்து இல்ல நாங்க போக வேண்டியது ஜஸ்ட் ஒரு ஓவரா சொல்றேன் ரெண்டு நம்பர் பெரிய நம்பரா இருந்தா அதை ஹேண்ட் பண்ண முடியாது. நான் ஒரு பண்ண சி ப்ரோக்ராம் சி வந்துட்டு சைஸ் தான் இருக்கு ஒரு நம்பர் அது சைஸ்ல தான் இருக்கும் அப்படிங்கிற ஒரு ரெஸ்ட்ரிக்ஷன் பெரிய நம்பர் யூஸ் பண்ணா நம்ம அப்படி டிஃபைன் பண்ணிருக்கோம் லாங் எயிட் டபுள் எயிட் அப்படின்னா நம்ம டிஃபைன் பண்ணிருக்கோம். இப்போ நம்ம பெரிய எயிட் கொடுத்தா சின்ன கெப்பாசிட்டி இருக்கு இந்த மாதிரி யூஸ் பண்ணுவோம். அந்த மாதிரி பிரச்சனைகள் தான் இருக்கு. அது தெரிஞ்சுக்காம நம்ம என்ன பண்றோம் நம்ம ப்ரோக்ராம் ரிலீஸ் பண்ணிட்டோம் அப்படின்னா இது மட்டும் கிடையாது நிறைய விண்டோஸ் ஆப்ரேட்டிங் சிஸ்டம் நிறைய சாஃப்ட்வேர்ஸ்ல இது வந்து பாத்தீங்க அப்படின்னா பிரச்சனைகள் வரும். அவங்க சாஃப்ட்வேர்ஸ் சரியா டெஸ்ட் பண்ணாம ரிலீஸ் பண்ணியிருப்பாங்க. ஓகே நிறைய ப்ராப்ளம்ஸ் இருக்கும். ஒரு பெரிய ப்ராப்ளம் மில்லியன் கணக்கான டாலர்ஸ் வேஸ்டா போச்சு. ஓகே நாசா பண்ண ஒரு எக்ஸ்பெரிமெண்ட்னால வாட்ஸ் தி நேம் டீப் ஸ்பேஸ் ஆர் சம். ஸோ நாசா ஒரு சின்ன பிரச்சனை தான். ஓகே என்னன்னா அந்த சேட்டலைட்டை தயாரிச்சவங்க ஒரு பக்கம் அந்த சேட்டலைட்டை நேவிகேட் பண்ணக்கூடிய ஒரு டீம் ரெண்டு பேருமே இருக்காங்க. தயாரிச்சவங்க என்ன பண்ணிருக்காங்கன்னா நம்பர்ஸ் டிஸ்டன்ஸ் வந்துட்டு சம் ஃபார்ம்ஸ் ஆஃப் யூஎஸ் யூகேயோட ஸ்டாண்டர்ட்ஸை எனேபிள் பண்ணிருக்காங்க. டிஃபரன்ஸ் இருக்கு இல்லையா வெயிட் ஆஃப் தி பவர் கிலோகிராம்ஸ் சொல்றீங்க அந்த மாதிரி அங்க வந்து டிஸ்டன்ஸ் மெஷர் பண்றதுக்கு யூகேயோட யூனிட்ஸ் யூஸ் பண்ணிருக்காங்க. இந்த நேவிகேஷன் வந்து பாத்தீங்கன்னா அமெரிக்கன் அந்த பர்టిక్యులர் யூனிட்ஸ் யூஸ் பண்ணிருக்காங்க. ரெண்டு யூனிட் கன்வர்ஷனுமே நடக்கும். ஆக்சுவலா அப்படி நடக்காம என்ன பண்ணிட்டாங்கன்னா ஃபார் இன்ஸ்டன்ஸ் comparing to the kilometer miles is lesser or higher kilometer miles miles is lesser, right? Somewhat 0.62 thing apart from kilogram, right? If 2 miles in kilometer per 2 miles now, 1, right? 1.2 kilometers, something, right? 2 miles 0.6. Mile is equal to 0.6 kilometer, right? Miles is higher or okay, let's check the Google itself. Why you have to get confusion? Ah, 1.6. Sorry. Yeah. It's 1.6 kilometer. So 1 mile is 1.6 kilometer. If I'm specifying 2 miles, it is if a miles equal a kilometer, 2 kilometer and the robot kilometer 3.2 So in the confusion, it caused major failure in the space. Interesting case study. They lost billions of dollars. Okay. And the Mars, I think Mars orbitly and the probe report. Or chinna problem. Okay. So it's quite interesting. Okay. So testing is really important. Use for it. Test failure. So the testing algorithm is important. So you also do it basically when you start doing it. Okay. So even though we have addition of 2 numbers, we just test it and see whether it's working for all possible numbers or not. Okay. What should be the quality of good algorithm? First is time. It should take less time. Some of your algorithm will take time comparison also has to be done because your algorithm will be scored based on the time and memory. Okay, basically 2 things. One is time should take less time to execute a particular program or the algorithm, and it should occupy less memory only. Okay. Memory is less. What will happen? It can conserve a lot many spaces, right? How many of you use Spotify and Spotify Lite? There are 2 things, right? How many of you use Spotify? There's something called as Spotify Lite, right? There's something called as MX Player Lite, MX Player and MX Player Lite. They'll be reducing some features, and the spaces will be very less. That applications at all, right? So your program should also conserve only small amount of space, right? And third one is accuracy. Okay, it's not be like uncertain answers, fuzzy answers. It should be exactly specific. Okay. Sequence. You know a lot many things about sequence, right? Algorithm should follow any particular sequence, either top to bottom or bottom to top. And the next is representation of an algorithm. So algorithm can be represented in 3 ways. One is normal English, flowchart, and pseudocode. Normal English, flowchart, and pseudocode. In normal English, we specify it in a very descriptive way. What has to be done in a very descriptive fashion? Take a cookbook. The cookbook is written in plain English, right? Everything in a clear, descriptive way has presented, right? In same thing, we can do it. Okay. So it will be very easy to understand, right? There is no symbols and all. It will be very easy to understand, easy to write, and easy to read. And second one is flowchart. That is also another representation. Instead of writing everything, we can specify using some symbols. Okay. It's specified using what are the 2 ways. Football is right. You get everywhere sports league. Or it is timeout. Some people use as break, something like break or timeout. People use, right? So symbolically, you can represent certain things. Okay. You can convey the meaning of the algorithm through the symbols using flowcharts. Okay. So that easily we can understand it, and the understanding can be taken very small amount of time. Next is pseudocode. So pseudocode is a very high level description. It just only uses some shortcut terms. Okay, not descriptive, no symbols, but very concise and very short terms to represent the process. Okay, algorithm is just a process, right? Execution of the procedure. This is the process, right? So how the process is represented, these 3 ways. The last thing is pseudocode. Pseudocode looks somewhat similar to your program. Okay, that's why I just written these 2 things. Okay, so programming language is like a Spider-Man. Pseudocode is like a keep going for the this company. Okay. So example for just adding the two numbers. In normal English, what we do? Start, read number 1, number 2, add the value of number 1 with number 2, and store the result in number 3. Display the value of number 3. Stop. Very descriptive, very clear. You can easily, anyone who knows English, they can understand, right? The flow chart. Start, read number 1 and number 2. So this symbol has a meaning, this symbol has a meaning, this symbol has a meaning. Each and every symbol here, the flow chart has a different meaning. Somewhat we need some knowledge to understand the symbols. So every component they won't understand. The flow chart is somewhat complicated. Okay. So add number 1 plus number 2, let's go to number 3. So this is positive symbol. See this process, we can see that some processing is happening. You see this, we can understand, okay, input and output is happening. So you see, we are printing number 3 in this box. And stop. So stop and stop. So they both have a particular symbol, right? The last one is pseudocode. Using some terms we will indicate. Some notation we will indicate. Okay. So start. Read means we are trying to get input. Read number 1 and number 2. We are getting input 2 numbers. Compute. This is a calculation, right? Number 3 is equal to number 1. Print. Display the right. So print number 3. Stop. It's very precise. Huh? It's closely associated to the program, but not in a very strict manner. The syntax are not very strict. You can use any type of terms also here. There is no restrictions. No? That's all. Question time. Ready? 1 minute, we'll close it. Okay. Here, yourself. What's the answer? Okay, let them answer. Okay, rest of you keep quiet. Good. Algorithm is defined as a step-by-step procedure for solving a problem. Sit down. Here, any of you? Yes. Get up. An algorithm must remember the result to preserve dash of the information. Any idea? Okay. Any guess? What it is? What? State. Yeah, that's the answer. Preserve the state of the information. Okay. Sit down. அடுத்தது யார் volunteer? Come on, guys, participate. Balaji. Balaji, right? Yeah, Balaji. Yeah, come on, Balaji. Next one. 2 things I told, right? Let him answer, man. No issues. Even though it's wrong, no issues. Yes. Very good, Balaji. Very good. Next memory. Time. Very good. Very good. Nice, nice, nice. Time and memory. Next, அடுத்தது இந்த பக்கம் யாரு? Algorithm dash. சீக்கிரம் யாராவது வந்துறீங்க? Anyone? யாராவது ஒருத்தர் வந்துறீங்க. எந்திரிச்சுதான் ஆகணும். வேகமா முடிக்கணும் இல்லையா? இல்லைங்க நிக்கிறது நான் ரெடி. நீங்க ரெடியா? You don't want to go for break? பக்கத்துல. அங்க யாரோ ஒருத்தர் வந்துறீங்க. இந்த காலம் நீங்களே வா. சரி. Accuracy, good, nice. அடுத்த காலம்ல. Madan, can you pick someone? You can pick someone. You don't have to stand. You can send someone from your side. Or Madan itself is ready. Okay, what's your name? Darshan. Okay. True. Sure. What's the answer? What's the clue gives you? True or false? Sure. That's all. What's the answer, by the way? That is true. It can't be ambiguous. Ambiguous na குழப்பமான அப்படினு அர்த்தம். Algorithm குழப்பத்தை ஏற்படுத்திட கூடாது இல்லையா?